after knowing about the Zener diode and which is connected in reverse bias, now we are going to discuss about optoelectronic junction devices. Means what is meant by the optoelectronic junction devices? Means whenever the optical light, means what we can see the light like sunlight, whenever the light is incident on the devices which is photosensitive semiconductors, the material which is made up of is photosensitive. Semiconductors are made up of with photosensitive materials, then that will be the photosensitive. Means semiconductor diodes in which carriers are generated by photons. Photons means whenever the sunlight is incident on the some of the photosensitive substances plates, then due to that generated means carriers means charge carriers are generated by the photons in the semiconducting materials like diodes in junction diodes, semiconductor diodes, then that will be the optoelectronic junction devices or photo devices. So photosensitive devices. So in this case of three types, it can be classified into that. They are that first one is a photodiode, which is detecting the optical signal. Photodiode can be detected the optical signal. The next one is light emitting diodes, LEDs, light emitting diodes. Whenever the light is incident on that, then that will emit the light. That will emit the light means converts the electrical energy into light. Electrical energy into light. Next one is photovoltaic devices like solar cell, photovoltaic solar cell. That is which converts the optical radiation into light. Means whenever the sunlight is incident on the solar plates, then that can be converted into the light or some of the electricity. It can be stored as electricity and it gives the solar cells means photovoltaic device, so which sparkles will come from that and it illuminates. So that's that type of materials are photovoltaic devices. In this case, first of all, we are going to optoelectronic junction devices. We are going to discuss about photodiode. Photodiode, a p-n junction diode made photosensitive materials like photosensitive p-n junction diode is made up with the photosensitive semiconductor materials, then that is called as a photodiode. Means whenever the light is incident on that, then it can be reverse biased. So that's why whenever the light is incident on that material, then that can be absorbed. That will be absorbed. Due to that one, the conduction is possible in the p-n junction diode. Means here that this is the p-n junction diode, and whenever it is heavily doped, means whenever the light ray is incident on this material, this is the photosensitive material. Here between this photosensitive material will be occurs whenever the photosensitive substances means light is incident on that. It can be connected in reverse bias. This p type of metal connected to negative charge of negative terminal of the battery, and n type of a material is connected to the positive terminal of the battery, and it is connected in reverse bias. Whenever it is connected in reverse bias, whenever the light ray is incident on that, when the conduction will be increases, means whenever the light ray intensity is more, then the conduction in the p-n junction diode is also more. Due to that, it will absorb the more amount of light ray. So that's why here the wavelength of light is incident on the body, then that can break the valency bond and conduction will be possible, because of whenever the valency band is breaks and another new number of electron hole pair will be created. Already we discussed in the bond, means the p-n junction diode. Already we discussed in the p-n junction diode, whenever the suitable of frequency is incident on that, then the valency bond breaks and a new of holes and electron pair can be created. Due to that one, the conduction will be more and more in the at the junction. So wherever the no more in that, here the photodiode which function controlled by the light falling on it. A diode which can be controlled by the when the light is falling on that. If the more intensity of light is falling on that, then more conductivity will in be p-n junction diode. So that's why we can say that if the conductivity of p-n junction photodiode increases with the increase in intensity of light falling on it. Whenever the more light is incident on this material, then more conductivity will be happen in the p-n junction diode. So this will be the symbol of diode means light ray is like in inward direction. The direction will be in inward direction. If in case of the direction will be in opposite direction, if the direction is like this, then that will be the symbol for the LED. So this is about the symbol of a photodiode. The arrows must be means light is incident on the diode. So here is also light is incident on the diode. So here the PN junction diode, which is made up of with the photosensitive semiconducting materials, then that will be the photodiode. It is connected in reverse bias, so it is can be controlled by the when the light falling the light incident on it. So that's why suppose the light of wavelength lambda is sufficient to break the valency band, means the wavelength of lambda light is incident on this, then in this case of PN junction diode the valency bond can be breaks. So when the light falls on the junction, then new hole pair can be created, new hole electron pair can be created, so that the conduction will be more and more in such a diode connected in the circuit. The current may be controlled by the incidenting light. If the incident light is increases, then the conductivity in the photodiode is also increases. So this is about here the graph we can say that it is the potential and this is the current in microammeters. Microamps, that will be the microamps with the here the ammeter we can measure the how much the current is flowing through the circuit. If the intensity of radiation is moving more, then the voltage is also more, intensity of current is also more, like this. Here conductivity of PN junction diode for PN junction photodiode increases, means whenever the more light incident on this, then more potential intensity of potential will be increases like that I5 greater than I4 greater than I3 greater than I2 greater than I1. If the more light is incident on this material, then there will be more conductivity will be happen, means more current will be happen. So this is about the one of the optoelectronic junction devices, in that case of a photodiode. Next we are going to discuss about that the applications, means what are the applications of photodiode, means what are the photodiodes in which the devices the photodiodes can be used, means here the normally we can say that the clock radios and as well as camera light meters, which is projected in case of like we can see the like the umbrella type of materials. In that case of photodiodes can be illuminated. When the light is incident on that, then that will be absorbed some more intensity, conductivity will be happen. So camera light meters and also clock radios in the receivers of remote controls also. Whenever the remote control will happen, then receivers in the receivers of the remote controls also the photodiode can be useful in TVs or either whatever the electronic devices which is using by the remote controls, like that. Then also to measure the extremely low light intensities. Low light intensities that can be measured by using this photodiode, and also consumer items like camera light meters and clock radios and receivers of the remote controls in VCRs and televisions, and as well as to measure the low light intensities extremely in avalanche photodiodes. Avalanche, we know that avalanche breakdown. In the case of avalanche photodiodes are photo multiple tubes are using in spectroscopy and astronomy to see about the astronomy, and also night vision equipments without glare we can see the everything in the night also. So that's why the type of materials which is used for the night vision equipments also the photodiodes can be useful, and also large range finding, laser range finding, large amount of laser range finding also in this case of photodiodes can be used, and also pin diode. Pin diode means here pin diodes are much faster and sensitive more than the PN junction diode. Pin diodes are faster and sensitive materials that they are used for the communication purpose. That pin means positive intrinsic negative diode. Positive intrinsic negative diode means a heavily neutral doped, a large neutrally doped intrinsic semiconductor is sandwiched. A large neutrally large neutrally doped intrinsic semiconductor is sandwiched with the p doped and n doped materials, p doped and n doped diodes. Then that can be the pin means a positive intrinsic negative diode can be formed. Then the diodes are used in much faster and more sensitive also. These diodes can be used in a communication purpose. So these are the applications of a photodiode that can be used. The photodiodes can be used in this purpose, like astronomy, like camera meter, camera light meters, and radios, clock radios, and as well as spectroscopy. And pin diodes are used for the communication purpose. They are the more efficient, more faster, and more sensitive also. So these are the applications of photodiode.